Problem 1. A tank has a height of 10 feet. The area of the horizontal cross-section of the tank at height h feet is given by the function a, where a of h is measured in square feet. The function a is continuous and decreases as h increases. Selected values for a of h are given in the table above. Part A. Use a left Riemann sum with the 3 subintervals indicated by the data in the table to approximate the volume of the tank. Indicate units of measure. So we want a left Riemann sum, and there are 3 subintervals. I notice they're not equal subintervals, so I'm going to break them up into 1 interval, 2 intervals, 3 intervals. Okay, if I'm doing a left Riemann sum, the distance between 2 and 0 is going to be 2 times, in that interval, 50.3 is on the left side, and then plus the distance between 2 and 5 is 3 times the left interval would be 14.4, and then plus the distance between 5 and 10 is 5 times the left interval is 6.5. And then if you do that calculation, you should end up getting 176.3, and it does say to indicate units of measure, that will be feet cubed. And if you are not sure, we always take the integral times the limits. So we're going to take square feet times feet, that will give us feet cubed. Okay, you would get 1 point for correctly doing a left Riemann sum, so you set it up from the left, and you get 1 point for getting 176.3. We are not going to worry about our units right now. So right now you did not get any points for units or not having units. Okay, that was part A. Part B says, does the approximation overestimate or underestimate the volume of the tank? Explain your reasoning. Well, if you look at this, A is a decreasing function. So if I were to draw my rectangles starting at the left, you'll notice it's going to be an overestimate. So I'm going to say it's an overestimate. I'm just going to say we did a left Riemann sum, and A of h is decreasing. So for those 2 reasons, it's going to be an overestimate. Oops, so that was just worth 1 point. Okay, part C, the area in square feet of the horizontal cross-section is modeled by the function f given by this formula. Based on this model, find the volume of the tank. So volume of the tank is going to be feet cubed. So if I want to find a volume to get from area to volume, we're going to take the integral. So we're just going to take the integral from 0 to 10 of that function, and so that I don't actually write down this function incorrectly, I'm just going to put f of h dh. So that's the setup that I'm going to do. You could actually put that formula in if you want to, and then you should get an answer of 101.325, and it did say to indicate units of measure again, so this will once again be feet cubed. Right, this was worth 2 points. You got 1 for setting up the integral correctly, and then 1 for getting that right answer. And again, there were no points so far given on the units. Okay, for part D, it says water is pumped into the tank. When the height of the water is 5 feet, the height is increasing at the rate of 0.26 foot per minute. Using the model from part C, find the rate at which the volume of water is changing with respect to time when the height of the water is 5 feet. Indicate units of measure. Okay, this looks like a related rates problem because of what they are giving us. So I'm going to write down on my information. They gave me the height is 5. They told me how fast the height was increasing. So I'm going to put that as dh dt equals 0.26. And then they are asking for how fast is the volume changing. So they're asking for dv dt. So I need a dv dt. Well, we were given in that last problem that A was equal to something, and I just need to find that real quick again, what that formula was. A was f of h, which was equal to 50.3 over e to the 0.2h plus h. Okay, so that was the area, and if I want to find I need a formula for dv dt. Well, if this is area, that actually is how fast the volume is changing because the derivative of volume is area. So if I want dv dt, it's actually going to be that formula, 50.3 over e to the 0.2h plus h. But since this is with respect to time, we need to include dh dt. Okay, then from here we're just plugging in information. I'm going to have 50.3 over e to the 0.2 times 5 plus 5 times 0.26, and when I calculate that out, I end up getting 1.694, and it does ask me for units, indicate units of measure. How fast is the volume changing? It's changing 1.694 feet cubed per minute. Okay, so let's see where we got points on this one. You'd get 2 points for getting this set up. I'm going to guess I'd give you 1 point if you recognize that you're going to use this formula, and 1 point for attaching the dh dt to it because it was with respect to time. And then you got 1 point for your answer of 1.694. Now remember, that should give us a total of 8 points, but each problem was worth 9. The last point is going to come from your units. If you have the proper units in parts, in all of your parts, then you will have, well, actually it was part A, C, and D. Then you get that last point.